Okay, good morning. I am totally out of sync and don't remember. Did we do this in here? Okay, so, yeah, the lockdown got me confused with sixth period being off task, or off with you guys. So just want you guys to realize and know that we can push the limits. We can move it in as long as we're not crossing over the variable we're evaluating at. I cannot move it in there because I'm moving past the variable. If this was a 3, sure, move it around. Okay? And there is an exit card on L'Hôpital's on Monday. Like, you will need to show the process of pulling the limits out, writing that you check that the numerator went to 0, the denominator went to 0, so we can apply L'Hôpital to do it, and then check again. Or that it went to positive infinity in the top and negative infinity on the bottom. Okay. So, all right, today, the things we did yesterday, 0 divided by 0, infinity divided by infinity, and things like infinity minus infinity, where we had to make a single fraction and go from there. Today we're going to talk about these guys, 1 to infinity, not necessarily 1, 0 to the 0, might be 1, might be 0, might be something else. And I think it's best to just try a problem. So, write the problem down. Chapter 3, we had things like this, moving target to moving target, and I'm like, whoa, whenever you see that, we need to do something in particular. Do you guys remember what we need to do for the derivative of this, Michael? What do you think? Not sure. So, in advance, we're going to do the log of both sides. Why? Because then we can bring that exponent down. And now we got product rule and implicit, and we can go from there. Great, yes. So, with that in mind, which this is not on the AP exam, by the way, this kind of thing. We're gonna use that same idea here, which is why I kept it. I was like, there's some interesting uses for this. So here, I need the natural log. I don't have both sides. So if I want to do natural log, I need to do the inverse functions. What do you get an idea?
I was gonna say like
Okay, I can't limit the function. I can't say let limit equal y. But I want to undo. I want to put on natural log. So what's the function that undoes natural log? Exponential. So I'm going to say e to the ln of all of that jazz. Kind of weird. And the reason for the reminder about limit, I'm gonna trade places here. I'm going to pull the limit out, and now I'm going to Okay, and Michael reminded us the reason that we wanted to do log in the first place was so that we could bring that exponent down. And this is in the L'Hopital's unit. L'Hopital's helps us evaluate limits. Does it apply to the stuff that's in this exponent right now, that limit there? In the form that it's in, can I do L'Hopital's? You guys are shaking your heads, no. Zach, why not?
It's not a fraction.
Not a fraction. All right. Correct. Bummer and correct. So, we're gonna do this underhanded cheating slimy kind of thing, and it comes up in your homework tonight a lot. I'm gonna make it a fraction. So multiplying by 1 over x up top, I get just that natural log thing. And on the bottom, I get that. Okay, Naomi's making a stinky face. She's like, this is gross. I agree. I concur. Okay, so let me just check. Putting an infinity, putting an infinity in the denominator, 1 over x. 1 over infinity, what does that become? I have 1 cookie, and I need to share it with everybody.
Really small.
How much cookie do you personally get if I've got to share it with the whole?
Really close,
Damn near 0. You ain't getting no freaking cookie. I'll be nice and I'll split it between everybody equally. You ain't getting no cookie though. But neither is anyone else. Okay, and Max, when I plug in infinity in the numerator,
You also get 0.
I also get no cookies. Okay, so to properly, which this will be checked on Monday's exit card, to properly test, I have to pull this out. Plugging in infinity, 1 over infinity, as Paul said, 0. Natural log of 1, well, that's 0. Checking the denominator. L'Hopital's applies. So Nathaniel, what is the derivative of the numerator?
1 over
1 over stuff times derivative of stuff. What is derivative of stuff?
negative x, negative squared.
Multiply by the power, -1, and lower the power. Okay, well, he just did the derivative of the denominator by doing chain rule up top, so that's multiply by the power, lower the power. That's a really long problem. And do you see anything that might simplify?
Yeah.
Yeah, okay, that's nice. All right. So what I have left is that. What is that? What, now when I plug in infinity? 1 over 1 plus 1 over infinity.
It's either one.
So the limit evaluates to 1, so the whole thing is just e. So that was 1 to the infinity. 1 times 1 times 1 times 1 times 1 became 2.7 and change. Yeah.
How do you know, like, when you have only, like, one line and stuff, like, how do you know it's multiplied? To, like, make it a fraction?
Oh, usually, right. People are done writing, I can scroll up. So first deal, to tip you off to like seeing that this is what's going on, Like here, it was a moving target to a moving target. This is limit of a moving target to a moving target. So that right there is the hint. We need to do this ELN thing because like Michael said, we need to be able to pull that exponent off. And then this becomes infinity times 0. When it's infinity times 0, I need to use this like strategy. And often it's multiplied by that 1/x. Sometimes it's 1/x squared, and those are really mean because it means there's a couple of more steps of this L'Hopital crap going on. But the complications that you guys are gonna see, it's gonna be, take the, whatever term makes the infinity and multiply by 1 over that.
Okay.
And it's almost always gonna be x. But in the first place, what we started with, 1 plus almost 0 to the infinity became e. Okay, and now I will show you what's covered up over here. E and ln of the function is just the function. Often, people will just pull this part off. So, they'll just do this part of the problem off on the side. And my concern, the reason I showed it this long, yucky way, is you'll get the answer to this orange stuff and you'll be like, that's 1. But it's not 1, it's e to the 1. So I showed you with all the junk so that it doesn't get lost. I'm okay if you want to pull it aside and do the work, clean it up, as long as you remember to put e to whatever on it. All right, see if you guys can start the process.